Hi everybody, this is Mr. Folly, and welcome to me keying out our review. Yay! The bond angle for CH3, NH3, and H2O decreases. Explain why. So the first thing I'm going to do is draw each of those. So carbon, 1, 2, 3, 4, valence electrons, 4 hydrogens, put a dot for each hydrogen, connect the dots, la la la, connect the dots, la la. Next I'm going to do is NH3, and I'll talk about the shapes here in a minute. H with a dot, H with a dot, H with a dot, connect the dots, la la la, connect the dots, la la. Oxygen, those are two, again some hydrogens. And again, you get the number of dots for the central atom, well, for every atom by looking at the periodic table. So in the periodic table, it goes, whatever your group number is the number of valence electrons. So 1, 2, skip a few, 3, 4, 5, 6, 7, 8. So that's how I got those. Hopefully you can see my dots. So then we're doing bond angles, so that means I need to think about the shapes. So this has 4 bonds. All of these have 1, 2, 3, 4 bond regions. So it's going to be based on the tetrahedral shape of this right here. So when you have that bond angle, you're going to get 109.5 degrees. Now here, it's the same thing, but I have a lone pair on here. Remember, pairs push harder. Pairs push harder. So this one, we'll say is slightly less. All you need to do is say less than 109. But what I'm going to do here is actually be able to rank them. So here on this one, notice how when I look at this, if I have 2 lone pairs, I don't have anything that's linear. So this is not linear. So this would look, if I'm drawing it the same way, like this, and then a pair here, and a pair on top. So this is going to be 105 degrees. So explain why. My explain why is pairs push harder. So the angles, decrease with more pairs. Now remember, pairs are lone pairs, and bonds are pairs of electrons as well, but that's not what we're talking about. Okay. Explain why the carbon oxygen bond length in CO3 -2 is greater than the carbon oxygen length in CO2. So just like every other time, we're stuck drawing these. So carbon, carbon 1, 2, 3, 4, oxygen, 1, 2, 3, 4, single, 1, 2, 3, 4, single, 1, 2, 3, 4, single. And again, I'm aiming my single electrons to form bonds. And remember, my first choice is whenever I get a chance to, I like to make a double bond, but strangely only one, because then I can do resonance. So CO3 -2, if I was very silly, I would consider for just a second connecting those two and forming a ring. But we know that rings are wrong. And if we did that, we would have an isosceles triangle with a bond angle of 60 degrees equals bad, actually impossible, right? 90 degrees is bad, but 60 is impossible. But remember, I am an ion, -2. So I get to put 2 electrons anywhere I want to. So I put them right there. So on this, note this has resonance. So it has a double bond with options. Now, don't ever write that, but that's how you identify it, right? I could have put it up on top, so I could have put it up on top or on the side, but I put it on the left. I don't know why I did, but I did. Okay, so what that means is when you recognize that, I have 1, 2, 3, 4 bonds in 3 spots, 3 locations. And that's the strength of the bond, okay? So that equals a bond order of 4/3, okay? Now when I have carbon dioxide, we've seen this enough, I'll shortcut this one. This one has a double bond. So explain why the carbon oxygen bond length in CO3 -2 is greater. So weaker bonds are longer. And 4/3 is weaker than double. All right. Yay. Shown above is the Lewis dot structure for ethanoic acid. Just again, we have acids that are COOHs. What is the approximate bond angle of the HOC? H to O to C, so this right here. So I have 1, 2, 3, 4 bond angle, 4 spots, right? 4 spots is based on 109.5, but I have a pair, but 2 pairs. So less than 109.5 or 105 degrees. Okay. What is the approximate angle of the O to C to O bond? O to C to O. This one, let's see if I can change my color on here. I have 1, 2, 3 regions. Okay. So 3 regions gives me the 120 degrees. And I don't have, now, no pairs, but a double repels a bit more. So 120 degrees would receive full credit, and so would slightly less, than 120 degrees. I will not take less than, not then, but then. What is approximate HCH bond angle? H to C to H, okay? So again, on this one, let's see if I can go to another color. Uh-oh. It's not letting me. Word's not responding to my color blindness requests. So it's stalling out on me and not liking how much I'm writing. So maybe I'll just call this part 1. I think I will. So welcome to part 1. So part 2 is coming up. Toodles.